Dear friends, in last two videos we have seen how t-test is used to check the significance of difference between two uncorrelated means. In that we have seen two situations. Number one, when the sample is large, and number two, when the sample is small. Now in this video we will see how t-test is applied to check the significance of difference when two correlated means are given. As we have discussed in our first video, there are three situations of correlated means. Out of those, number one is pre-test and post-test scores. If pre-test and post-test both are used, and the scores are obtained from these two tests, and their means are to be compared, then such two means are called correlated means. Situation number two, when two groups are made by matching pair sampling method, then the means obtained by the scores of two groups are said correlated. And these two situations, in both the situations, the following formula is used to find SED, standard error of difference between means. It is equal to under root sigma 1 square plus sigma 2 square minus 2 into r into sigma 1 into sigma 2, where sigma 1 is equal to standard error of mean of first group, that is found by this formula SD1 upon under root N1. SD1 is standard deviation of first group, N1 is number of observations in first group. Sigma 2 is found by sigma 2 means standard error of mean of second group, and it is found by this formula SD2 upon under root N2, where SD2 is standard deviation of the scores of second group, N2 is number of observations in second group. Remember friends here that both the groups have equal number of observations in these two situations. And last one is R. R means correlation coefficient between the scores of both groups. Now we see one example. Here pre-test scores and post-test scores of the secondary school teachers in mental stress test are given here, and we have to check whether the means of these two groups are equal or different. If it is different, then whether it is significantly different or not. For that, the hypothesis is made, formulated. There is no significant difference between mean scores of secondary schools teachers in pre and post test of mental stress. And for calculation of SED and T score, we need this formula. First of all, SED, standard error of difference between means, we have seen earlier, and the basic values we need are N1, that is 12, number of observations in first group, N2, number of observations in second group, 12, X bar 1 is 36.3, that is mean of the scores of first group, that is found by using normal formula of mean. X bar 2 is equal to 31.6, that is mean of the scores of second group. It is also found by using normal formula. SD1 is 7.74, that is standard deviation of first group. SD2 is 3.82, that is standard deviation of the scores of second group. Both the standard deviations are found by using normal formula of the same. And R is equal to 0.27. Here R correlation coefficient is found by Carl Pearson's method. Now see how SED is found. Here values are given, the formula of SED is given here. First of all, we find sigma 1, standard error of the mean of first group, and for that we will use this formula SD1 upon under root N1. SD1 is 7.74, and n1 is 12. By putting this value and solving it, we will get sigma 1 equals to 2.236, and we need here sigma 1 square. So the square of this 2.236 is 4.99. Now we'll find sigma 2, standard error of mean of second group, by using this formula. Sigma 2 is equal to SD2 upon under root 10 2. SD2 is standard deviation of second group, that is 3.82, and N2 is number of observation in second group, that is 12. By solving it, we'll get sigma 2 equals to 1.1, and the square of this is 1.21. The sigma square and sigma both will be used in the formula. Now we'll put the values in formula in this way. 4.99 is sigma 1 square, 1.21 is sigma 2 square, minus 2.27 is correlation coefficient, 2.236 is sigma 1, and 1.1 is sigma 2. By solving it, we will get under root 4.87, that is 2.21. It means SED, standard error of difference between means, is 2.21. Now we'll find t value. The basic formula of t value is in modulus x bar 1 minus x bar 2 minus 0 upon SED. It is not compulsory to write minus 0, we can avoid it, but here it is written. Now we'll put the value in the formula of t, where 36.3 is mean of first group, 31.6 is mean of second group, and 2.21 is SED, standard error of difference between mean. By solving it, we'll get here t value 2.13. Now after getting t value, we have to find df, degree of freedom. Degree of freedom in correlated means is n minus 1. N means number of observation in any one group, not total. So number of observation in both the groups are equal. So n is 12. 12 is number of observation in any one group. So df is found in this way, in this when correlated means are given. So df is equal to 11. Now we are having t value and df, then we move to t table. In t table, 5 columns are given. First column is df. Here the table is divided in 3 parts. In first part, in all the parts, 5 columns are given, in which first column is df, degree of freedom. We have to see at df. Under df, our degree of freedom is 11. So under df, we have to see where is 11. It is there. 11 is here. And in the line of 11 under column number 2, that is column of probability 0.05. Under this probability value, we have to find the t value in the line of 11, that is our df. So 2.2 is there under 0.05, and then we have to look at 0.01, probability 0.01, that is in the fourth column. Under that, we have to see in the line of 11 what is the value of t, required value of t for significance of difference at 0.01 is 3.11. Required t value for significance of difference between means at 0.05 level according to the table is 2.2. We have to remember these two value. df 11 under 0.05 probability, the t value, required t value is 2.2, and under 0.01 it is 3.11. So we have to remember these two values, 2.2 and 3.11. Now we'll move to the t calculated and df. Our t calculated is 2.13 and according to table, t table value at 0.05 level is 2.2, that is required value for significance of difference at 0.05 level, and 3.11 is required table value, t table value for significance of difference between means at 0.01 level. Here t calculated is less than t table value. It is less than both table values which are required for significance of difference at 0.05 and 0.01 level respectively. Our calculated value is 2.13, that is less than 2.22, 2.2 and 3.11. In such situation, we will not reject the null hypothesis, that is, there is no significant difference between mean scores of secondary schools teachers in pre and post test of mental stress, and it will be concluded that there is no significant difference between the mental stress of the teachers according to the performance they were shown in pre-test and post-test. Friends, in this video we have seen how t-test is applied when two correlated means are given in two different situations. In next video we will see how t-test is applied for correlated means in third situation. Till then, goodbye.